In this video, we're going to learn about factoring, and this is just a mathematical way of separating out any polynomial into its smaller parts, to dividing out those factors that have been multiplied to make that polynomial. So this is the way that we divide those out. And the way that I'm going to show you here works for any trinomial. So it doesn't matter how big the numbers are or if it has a leading coefficient or not. You don't have to worry about any of that because the method that we use here, it works on any of those. So before we get into that, let's just kind of talk about what some of these words mean. You might have seen this one before, maybe in your algebra textbook, monomial. This just means it's an expression with only one term. So mono means one, and it's an expression with only one term. So let me write you an example here. I could have a negative or a positive, doesn't matter what the coefficient is. So I'm going to say negative 2x to the fourth. So I can make these numbers whatever I want, the coefficient, the exponent. As long as that expression only has one term, we would call that a monomial because there's only one piece to it. The other one is called a binomial, where bi means two, like on a bicycle, has two wheels. So this is an expression with two terms. All right, so my example here, I could say x squared would be the x squared term, and minus 5. So these are two separate terms, the x squared and then the number, the constant term. This is an expression with two terms, which we call a binomial. And the last one here, of course, we could go higher, but the last one that we're going to use here, tri means three, like a tricycle has three tires. This is an expression with three terms. All right, so here I could say 2x squared plus 4x minus 3. I could really change these numbers to whatever I want, but it's important they have 1, 2, 3 distinctive terms. Okay, so these are some of the words we'll be using: binomial, trinomial, monomial. These will be the vocabulary. So these will be some of the words that we're using here: monomial, binomial, trinomial, to talk about factors and factoring. So factoring is just the opposite of expanding or multiplying. We can use this to simplify polynomials by dividing them down into their basic factors. So my way for doing this, we just start by looking at the outside numbers. So here the coefficient is 3, the leading coefficient is 3, and the constant term, or just the number, is negative 5. And I would start by just multiplying these two together. 3 times negative 5, that would give us negative 15. All right, so that's our first step. Let's just multiply those outside numbers together. It's going to give us negative 15, and we're going to look for factors of that negative 15 that add up to this middle number. So I'm trying to make negative 2 by adding the factors of negative 15 is the trick here. So let's start by writing all the factor pairs. I could do 1 times negative 15, or I could do negative 1 times positive 15. I could also do 3 times negative 5. Or I could do negative 3 times positive 5. I could switch that around. But it looks like this is going to be the one that works because if we add 3 and we add negative 5 to that, it's going to give us that middle number, that negative 2. So this is the factor pair that we want to use here. All right, so let's go ahead and write this as a pair of factors. This is going to be p is the variable here, the letter, plus 3, and then p minus 5 would be the other factor. These are going to be our two factors. The last step here is in the beginning we multiplied in the leading coefficient, right? That's where we got that 3 from, was we multiplied that in temporarily to get the number that we're factoring. So we just need to take that back out. Here I multiplied that in, so here I'm just going to divide that back out. 3 divided by 3 and negative 5 divided by 3. So this one's pretty easy. 3 divided by 3 is just 1. And our factor there is going to be p plus 1. Over here, I can't divide 3 out of 5. It would give me a fraction or a decimal. So I'm just going to move this into the front, in front of the p. That's going to give me 3p minus 5. All right, and these are our factors. Now we can also check these. We could expand these back out. We could FOIL. We could use the box method. We could multiply these back out, and you would still end up back at this original problem. Okay, so let's look at a harder one. Same directions, factor the trinomial. But the first thing that I notice here is these all have a common factor that I could take out before I even start the problem. So we call this the GCF, or the greatest common factor, between all these numbers, 9, 66, and 21. And that's what I want to do first here, is just try to imagine what's the largest number that I can divide out of all three of these with no remainder. We call that the greatest common factor. 3, I can divide 3 out of 9, I can divide 3 out of 66, and I can also divide 3 out of 21, and that's going to be the biggest number that I can take out of all three of these. Right, so 9 divided by 3 is 3, k squared. 66 divided by 3, that's going to give me 22k. And then 21 divided by 3 is 7. All right, and now that I've done that, now I can start the problem just like I did on the last one. So the first step after the GCF is to multiply these outside numbers, the 3 and the 7. We're going to multiply those together. 3 times 7, that gives me 21. And again, I'm looking for factors of 21 that are going to add up to this middle number. So I'm trying to make 22 using factors of 21. All right, so I could do 1 times 21. Of course, I could also do 3 times 7, and that's really it. There's no other factors I can take out of there. So it looks like it's going to be this first pair, 1 and 21. If I multiply them, I get 21, but if I add them, I get this middle number. I get that 22. So that's what we're going to use here. So writing these as factors, I'm going to have k plus 1 is the first factor. The other one is going to be k plus 21. All right, and just going back to our first step where we multiplied in that 3. Now at the end, I've got to take it back out. It's kind of like I borrowed the 3 from the beginning, and now I need to divide that back out. Divide by 3, divide by 3. So let's go ahead and do this. On this one, I can't divide 3 out of 1. So I'm just going to move that in front of the k. That's going to be 3 times 3k plus 1 on that first factor. On the second factor, I can divide 21 divided by 3. That's going to be k plus 7. So these are going to be our factors here. Now notice if you did not factor out the GCF at the beginning, you would still have to factor it out here at the end. On the last one, so this one's a little more difficult. We're going to start off just like before, we're looking for a greatest common factor, a GCF. So on this one, I notice 15, 27, and 6. I can divide a 3 out of all these. That would be the greatest factor that I can divide out of all 3. So I'm going to start off by 15 divided by 3 is 5, and squared. 27 divided by 3 is going to be 9, and then 6 divided by 3 is 2. So from here, our first step after getting out of that GCF, the first step here, looking at the outside numbers, the 5, the -2, that's what we're going to multiply together. So 5 times -2, it's going to equal -10. All right, and we're looking for factors of -10. They're going to add up to this middle number, to that -9. So we could do 1 times -10, or we could do -1 times 10. We could also do 2 times -5. So it looks like it's going to be this first pair of factors, 1, -10, which are going to add to -9. So I could just rewrite this as factors now. This is going to be n plus 1 and n minus 10. Don't forget that last step, we borrowed that 5 in the beginning. We multiplied that in, so now we have to divide that back out. Divide that back out. On the first factor, I can't divide 5 into 1. So that's just going to be 5n plus 1. And on the second factor, I can divide 10 divided by 5. So this is going to be n minus 2. Another way that we can factor, this is called the difference of squares. This is just a different method of factoring for when I have square binomials. So the binomial here has 2 parts, and they're both perfect squares, right? 4 is a perfect square, 25, and the x squared is also a perfect square. So this is actually just a really simple trick. It works for any square binomial, and it just works by separating this binomial out into its 2 factors, which are both just the square roots. So the first factor of this would be square root of 4 is 2, square root of x squared is x, and then plus the square root of 25 is 5. And then the second factor is going to be just the same thing except with a minus sign. So it's going to be square root of 4, square root of x squared, minus the square root of 25. All right, so that's pretty much it. That's the trick. We're just separating this out into its 2 factors. One's going to be positive and one is negative because a positive times a negative is what gives us that negative here. Let's look at one more. So this one looks a little bit trickier, but I'm still just using that same process. So to separate this into its 2 factors, I'm looking at the square root of this first term. So square root of 121 is 11, square root of y squared is just y, plus the square root of that second term. Square root of 36 is 6, square root of x squared is x, and the second factor is going to be the same thing, just with a minus sign on this one. And again, it's because the positive times that negative is what gives us that negative up here.